Hi everyone, and welcome to the Mat 211 review of counting methods. My name is Julia, and I work for the tutoring centers at ASU. So today we want to calculate how many different sequences can be formed that use all of the letters of the given word mathematics. So first, note that there are 11 letters in the word. And that says 11. Let me rewrite that so it's actually readable. We'll do 11, sure. So the first thing we want to do here is we want to determine how many of each letter we have, because that's going to affect how we kind of order them in the sequence. So let's start, and we're just going to go through and tally letters, move through each letter of mathematics. So we have an M to start. And so we've got an M here, and we've got an M here. So we have 2 M's. Next letter is A. So we've got an A here. And we have 1 and 2 A's as well. Next letter is T, next unique letter. And as we see, we have 1 and 2 T's in mathematics. Now we have an H. And if we look through, we only have 1 H. And next letter is E. So we have E, and we only have the 1 E here, so just another 1. And we're going to skip over all of the letters that we already crossed out. So the next letter that we haven't counted yet is I. So we've got 1 I. And we have a C. One of those. And lastly, our S here at the end. And one of those. So notice that our first 3 letters, M, A, and T, are repeated. That is, there's more than one of them. They don't just exist once in our set of letters here. Our remaining 5 letters, H, E, I, C, and S, are not repeated. So we're going to start by dealing with the repeats portion. So when it comes to repeats, it doesn't matter if we switch the order. So if we have 2 M's here, it doesn't matter if we use this M first or this M first, because they're exactly the same. There's no order to which one we pick first. So we're going to be using combinations to deal with our M's and also our A's and our T's, because we don't care about which order we pick those letters in. So let's think about what we've got here. We've got 11 slots because we want to use all of the letters in our set of letters here. So we've got 11 total slots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's nice to kind of keep a running tally of how many we filled. So for the M, so we'll start with the M's here. And for the M's, if we start by placing that letter somewhere, we have 11 total spots because we haven't filled anything yet. And we have 2 M's. So since we're using combinations, this is going to mean that we, with the combination, C, 11, choose 2. Another way to write this that you may also see is when you have like 11 and a C and a 2. These are exactly the same thing. It's just a different notation for it. But I believe you guys tend to use this version of it, so we'll go ahead and use that for now. So we'll just leave this for the time being. This is for our M here. We'll just kind of keep that in mind. And let's go ahead and just fill the M's in here. They might not necessarily be in this spot, but it doesn't matter which order these spots are in. So we're just going to put those in there to remind ourselves that we've already taken care of those. We're going to do the same thing for our A's. But now, since we've already filled 2 spots with M's, we only have 9 remaining spots. So these guys here. So we don't want to use C of 11 choose 2 again, because we no longer have 11 spots. We only have 9 spots. So we're going to go ahead and we're going to, for our A's, we want, I'll just put a comma here for now. We want C of 9 choose 2. So this is our A's. So we've taken care of our M's and our A's, and let's go ahead and put our A's in here so we don't forget that we've already filled those spots. Lastly, out of our repeated values, we have our T here, and we're going to do exactly the same thing. But in this case, we've now filled 4 out of the 11 spots with letters, so we only have 7 remaining spots. So for our T's, we want the combination of 7 choose 2. And this is our T's. And we'll put our T's in here so we don't forget. So now we have 5 remaining spots, and now we're going to move on to our repeated value, or not repeated values. So our H, our E, our I, our C, and our S. So the remaining letters are non-repeats, and so the order matters for these because different letters, you know, different sequences of these letters. So we want to use a permutation in this case because these are not repeated. So the difference here is because these happen more than once, we're going to use combinations with them. But because these only happen once, we use permutations with them in this particular problem. So we have 5 spots and we have 5 remaining letters. So we want the permutation of 5 and choose 5. Again, you may also see this written as like 5 permutation 5 here. That's another way of notating this, but we'll stick with the first method. So now that we've figured out, so this is our H, our E, our I, our C, and our S. Now that we've figured out all of our spots for our letters here, we want to kind of bring it all together. So the number of words we can form is the product of all of our, our different combinations here times our permutation here. So let's write that out. So we have C of 11 choose 2 times C of 9 choose 2 times C of 7 choose 2 times our permutations here, which is P of 5 and 5. Now we want to go through and multiply this out. You can do this in your calculator. TI 80 whatevers, all of those have the ability to do this, as do a lot of other calculators. So if you don't know how to do that, you can always just look up online. There's plenty of videos with instructions depending on your type of calculator. Just as a side note, if you did want to calculate your combinations here, if we treated this as an N and this is a K, so our N choose K, or sometimes you see it as an R instead, your actual formula for your combinations would be N factorial over K factorial N minus K factorial. And your permutations would be, so if you had permutations of N, K, that would be N factorial over N minus K factorial. But we don't really need to do that here. Actually, yeah, So we'll just go ahead and use our calculators. And so this turns into, if we just equal here, this first one is equal to 55 times our second one, which is 36, times our C of 7 choose 2, which is going to equal 21, times our permutation of 5 choose 5, which is 120. And this is a bigger number because with permutations, order does matter. So that's why it's a larger number than the other ones. And if we work this out on our calculator, we end up with 4,989,600 sequences. That's a U. So that is our answer. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you are looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main webpage here at tutoring.asu.edu, or by going to this full link. So thanks so much and have a great rest of your day.